Hi and Assalamualaikum. My name is Ensyirah Elyana binti Abdullah and I will be presenting the question 6 from the assignment 3 SOA. Firstly, let's read the question. So, an investor wants to find the present value on 1st January of a private retirement annuity plan. The plan is structured to pay RM2,000 every 6 months for a total duration of 5 years. Under the policy term, the first payment is scheduled to be credited into their account on the upcoming April 1st. If the fund offers a rate of 9% convertible and semi-annually, determine its present value. So next, we extract the information that we get from the question, which is the regular payment is RM2,000 and the payment is made every 6 months for 5 years, which is n is equal to 5 multiplied with 2 and it will equal to 10. And the interest rate convertible semi-annually, which is I upper 2 equal to 9%. So before we get into the time diagram, we must make sure that the interest rate is follow the time of the payment term. So which is 2 times a year. So the 9% we will divide with 2 because semi-annual payment and it will equal to 4.5% or 0.045. So let's take a look at this time diagram. So our goal is to find the PV at the 1st January. However, in the question, it said that the first payment is occur on the April 1st. So I use the annuity due to calculate this. Refresh back, the annuity due is meaning that the first payment is start at the beginning of each period. It means that if we plug in the n, which is the times payment equal to 10 into a PV annuity due formula, we will only get the PV on the April 1st. So how can we get the PV on the 1st January? So we will use the discount back formula, which is V power of t. How can we know the t? This is a 6-month period, interest period, which would run from the 1st January to July 1st. So the time distance from the April to January is exactly 3 months, which is it represents the half of the standard interest period. So therefore, we will get the time distance from the January to the April is 0.5 of a period. So that's why we will get t equal to 0.5. So this is the calculation that I made to solve this problem. So using an annuity due formula, PV, which is PV equals to R, multiply with A double dot angle N, multiply with V power of T. So the R that we got from the question is 2000, multiply with 1 minus 1.045 power of negative 10 over 0.045 over 1.045 multiply with 1.045 power of negative 0.5. So we plug in this value into the calculator and we will get the answer. The PV on the January 1st is RM60,177.60. Now, what if we want to use the annuity immediate in solving this kind of question? So firstly, we must remember that annuity immediate meaning by the payment happen at the end of each period. So this forces the formula to calculate the present value exactly 6 months before the first payment. So in this question, it said that the first payment is happened to be on April 1st. So the 6 months before that, it was October 1st on the previous year. In order to get the PV on the 1st January, we must bring forward the amount to the 1st January, which is exactly 3 months in the interest time period, which is here we also get t equals to 0.5. So how can we use bring forward formula? So bring forward formula is 1 plus I power of t or 1 plus j power of t. So using the annuity immediate PV formula, which is PV equals to R, multiply with A angle N, and we also multiply with 1 plus j power of t, and we plug in the value that we get from the question, and we enter the value into the calculator. We will also get the same answer as the annuity due calculation, which is RM60,177.60. So before I end my presentation, I would like to conclude this kind of question. So in solving this type of problem, we must make sure that we align the payment frequency with the compounding interest rate to ensure that they operate in the exact same time period. Additionally, it's also important to track the timing of the first payment. If the payment schedule is shifted, we must make sure that we adjust the value by bringing it forward using 1 plus j or 1 plus I power of t, or discounting it back using v power of t. But it also depends either we use annuity immediate or annuity due. I hope you gain an understanding from this question. Thank you.